Hello everyone. In today's tutorial, we're gonna learn about topological sort. This is a very simple algorithm and it used to like what we have learned before, depth of search. So make sure that you're very comfortable with depth of search before you continue. This tutorial is a part of the data structures and algorithms class. First, what is topological sort? Topology, you're given a structure, shape, or relationship. And whatever you do to that relationship or shape, the structures and relationships are not changed. Topological sort is sorting without changing existing relationship. That means if you are given a relationship in the form of a graph, if you do a topological sort on this graph, the relationship doesn't change. The term topological sort here is actually nothing fancy. People just name it differently to distinguish this kind of sorting with the regular sorting of array that we usually see. Now, topological sort is really simple and mathematically proven. If you are interested in the math proof, you can use this link to read more about it. For our tutorial, we only focus on the application. So the topological sort answers the question, what must be done first, with an emphasis on the must and the first. Now let's have a look at this example. Our example is we're getting ready for school. And these are the things that we need to do before we get to school. For example, put on a jacket, put on pants, put on a backpack, put on shoes, put on underwear, put on socks, and put on t-shirt. Our question is, what must be done first? Because some particular item must be put on first. For example, we cannot put on shoes before socks. So putting on socks must be done before putting on shoes. And same thing with underwear and pants. We cannot put on pants before underwear. So underwear must be put on before pants. And with common sense logic, we know that we need to put on shirt first before putting on jacket and then putting on backpack. So what is a possible way to get ready for school? Now, one way to get ready for school is we can put on underwear, then pants, then socks, then shoes, then shirt, then jacket, then backpack, and then going to school. And it's all makes sense getting ready with this way. Underwear goes before pants, and socks go before shoes, and shirt go before jacket, and jacket go before backpack, and then everything is done and we're ready for school. So the question is, how do we get this order of what must be done first? And the answer is topological sort. And it's really simple to apply to all of the problems. They're asking the question, what must be done first? So the way we solve this problem with topological sort is, from the information that we have, we're gonna build a graph. Let's have a relationships of things which show what must be done before what. And one important thing about this graph is, it cannot have any cycle. And as you can see here, our graph has no cycle. So the condition to use topological sort is really simple. It's directed graph with no cycle. And then to answer our original question, what must be done first? We simply do a depth of search for all the nodes. And then we reverse the order of our result. And then we have our answer here. It's that simple. So again, topological sort answer the question what must be done first. The condition to use is that the problem presented with directed graph with no cycle. And to get the answer, we do a depth of search for all the nodes and then reverse the order of the result. Next, we're gonna have a look at our implementation for topological sort to have the steps to get ready for school. Now the first and most important part is building the graph. The graph is gonna hold the relationship between what must be done first. And having no cycle in the graph is a must. From the original problem, we have the visual presentation of the graph, and then we have the code presentation of the graph. This is a map of the node information. Then our graph building is complete. Next, we have our topological sort function, which is going to include a depth of search. So in our topological sort, we have our depth of search. Just like before, we have our scene set to keep track of all the nodes that we have visited, and we initialize our result array. Then we define our depth of search. If you have noticed, this is exactly almost the same as depth of search, simplest implementation that we had before. We have the stack, we have the temporary result, and we have our while loop. After each depth, we save it to the result array. We print the result out to see how it looks like. After defining our depth of search, we run it with a for loop to make sure every single node is visited. Then we have the result and we reverse it, and we flatten out our result and we join it. And if we run our algorithm, this is the result that we're gonna get. So basically our algorithm gonna start a depth of search from 0. And the first depth that we're gonna have is socks to shoes to shirt to jacket, to backpack, and to school. That is what we see here. Then with the help of this for loop, we're gonna start another depth first search from 6, which is underwear. And for this depth, we have underwear to pants, which is what we have here. Then we do the reverse. The reverse of this one is underwear and pants gonna go first, and this array is gonna go after. So after we reverse, we have underwear and pants, and then socks, shoes, shirt, jacket, backpack, and school. And if we join everything, we have our result as underwear, pants, socks, shoes, shirt, jacket, backpack, and school. And that is how topological sort solves what must be done first problem. Next, we're gonna see typical problems solved by topological sort algorithm. Now remember, for all graph problems, always try to identify the nodes and construct the graph before applying the algorithm. Now typical problems can be solved by topological sort are course schedule problem. It's like when you go to school, you have to take classes, but you have prerequisite classes before it. And that is a what must be done first problem. Dependency resolution. One thing depends on the others. Also a what must be done first problem. Or computer operation system deadlock detection, fading cycle in graphs, and so on. It's basically any problem can be presented with graph. And the question is what must be done first. Then the problem can be solved by topological sort. Next, we're gonna summarize our topological sort algorithm. The question is to find truth about your data. And the question is what must be done first. And the input of your problem is graph. Or you can present your problem with graph. Then you can use topological sort to solve your problem with a good time complexity of O of n, with n is the number of total of the nodes. That is all for today's tutorial. Thank you for watching, and I will see you in the next video.